Hello all, welcome to my channel. I'm ready with a new video. This is part of the video series that we are doing on Iceberg. And in this video, we will be talking about ETL pattern, design pattern called write, audit, and publish. And we will see how it is implemented with Iceberg. So let's get started. So this pattern that we are talking here, write, audit, and publish, is an design pattern in ETL which allows us to independently and I work in isolation on data which is not yet ready to be published on the production system or for downstream consumption. So what this pattern says is that we have a new data that will arrive, and it will arrive in an isolated environment. It will not be part of the main production pipeline which is being consumed. And once we have this isolated environment, we will run audit process on this, which will be running all the DQ rules, all the business rules that are specific to that particular data set or a table. And once that audit passes, like it complies to the standards that we are expecting based on the business and the DQ rules, we will be publishing that record or making that record available for production to be consumed by downstream applications. So this pattern is what it it says that we will have the rights goes to an isolated environment which is inaccessible to the data users who are consuming the main table, and this can be a temporary area, staging area, or a branch. In case of audit, what we are doing performing is we are performing quality checks or business rule checks on the branch, staging branch or the staging area, and then once we are done with that, we publish the data to be consumed by the end users. So this is what write audit pattern, write audit and publish pattern is used, and it is heavily used in Netflix's data engineering ecosystem because they actually started this. No, I will not say they started this pattern, but they made this pattern widely adopted in production. Uh, we can implement write audit and publish pattern using DBT as well. So DBT has a concept of schema swap, which we can do, or DBT also has a concept of clone, zero copy clone. So we can use that zero copy clone as well to implement this write access and publish pattern. But in this blog, we will not be saying how we do it with DBT. We will be seeing how we do it with Iceberg. So now coming to the Iceberg, Iceberg offers a branching feature, which allows us to manage data's life cycle easily. So this branching in Iceberg is a way for us to act on a parallel version of data set that we have. So how branching is implemented in Iceberg is basically it is implemented using snapshots. So branching in Iceberg works similar to Git branches, where we can create local branches from the production table to carry out isolated data work on the table. The core Iceberg component behind the branch is snapshots, as I was mentioning earlier. So branches are named references to these snapshots. So the metadata of an Iceberg table stores history of the snapshot. So anytime we do add, create, or update a table, a new snapshot is created. And these snapshots allow the concurrent access control and table versioning. Branches are references to this, and using snapshots branching mechanism or branching feature is enabled in Iceberg. And when a table is created, it starts with only one branch, which is called main, and all transactions are written into it. But if we want, we can create additional branches, such as let's say an audit branch, and configure our compute engines to write to this particular branch. And once we are happy with that branch's data quality levels, we can fast forward that to another branch using the system call which is available in Spark called fast forward. We will see other approaches as well, but fast forward is something which is heavily used and widely adopted. How how to manage the Iceberg branches? So before we get into this, uh, how Iceberg does that. Let's see a few steps in a few prerequisites as well. We can say think of. So in here, all the examples are for glue catalog, but it can work with any catalog that we want. So first thing that we have to do is we have to enable this write audit and publish pattern. So for that we say write.wap.enable is equal to true. Then we also have to create a branch if it is not, does not exist. So we say alter table, the table name, and then we say create branch. If not exist, then the branch name. And we can simply check what all branches are available for a table is using select star from catalog db table dot refs. So this will have all the references to the branches which are available in this particular table. Or we can even create a tag. Once we have these things, we can query a particular branch by saying catalog db table and that branch name. Or if we are using Spark SQL, we can set the branch like this, saying spark dot wap branch is equal to audit. So next time when we query, for example, like this, it will point to this audit branch itself. And this is how we insert it into a table if we have set this branch. If not, we can simply say insert into catalog.db.table and then the branch name and then the values. And this will insert the records into a branch which is called branch audit. And once we are done with our changes, we know that okay, whatever we are done in the branch, the other branch is something which is production ready. So we have multiple option. The most famous option is to do a fast forward. So what we do is we call the catalog.system dot the stored procedure, which is fast forward. We provide the table name, whatever table it is, then provide the branch name in which we want to fast forward this. Oh, sorry, the branch which we want to fast forward to from. So the main branch, and it goes to the audit branch. So now the main branch will have everything which was there in the audit branch. We have other options like we can do a cherry pick of snapshots. We can also publish the snapshots, or we can issue a branch merge like this. We can say create or replace the branch main as of the branch which we did work on just now. So this is how we can do. We can implement. So basically, we will do is we will first enable WAP. We will create a branch, and then on that branch we will add or update, run the DQ validations. Once we are okay, we will fast forward that to this audit branch, main branch to the audit branch. And then once we are done, we can drop the branch, simply saying catalog.db.table, and then we say drop branch. So this is how we implement WAP or write audit publish pattern in Iceberg. And this is the flow, like the ingestion process will load data. So first we will have the Iceberg table, and then we have the main branch which has, let's say, a record as of 25th of September on 7th day. Let's say it means 7th of September 2025, and by mistake this should be 8th because we will be publishing this to the new record. So here it should be 8. And so we get a new record. So we create a branch called audit branch. We insert in this branch, then we do the audit process, and once this is valid, we just publish it to the main branch. And that's how Iceberg will implement the WAP or write audit publish pattern. Further, if you see flow wise, the data ingestion process switches branch from main and it commits updates to the audit branch instead of the main branch. And at this point, these updates aren't accessible to the downstream users. These are downstream user will be consuming from the main branch. Audit will happen on the uh, this branch, audit branch. And here we can specify which data is clean and ready to be provided. We can use tools like Great Expectation, PyDQ, or any other DQ check framework. DQX is another framework that we can use to do the audit. And once we are ready, we do a fast forward and make that main branch right to the fast, use the uh, audit branch. And then from that point onwards, when we have done the fast forward, the end users will be able to consume from the main branch, all the changes that we have. So why we have to the benefits of implementing this wrap pattern in Iceberg is that simplicity, because Iceberg branches allows us to quickly express multiple assets states of the table, and we can do that work in isolation. So the time we are doing this, the table is not inaccessible; it is still available with an older data, and uh, so the switching of the table just becomes one command that we do at a merge. So that is done. And we can, using this, we can handle concurrent writes. For example, let's say if we have to do a backfill of a table, and let's say we want to do a lot of validations, instead of doing it per one single bulk process, we can say we create partitions of the table based on, let's say, snap based on, let's say, the partitions, branches based off partitions, and each branch processes certain part of that particular table, and once we are ready, we just quickly do a fast forward. This also supports the schema evaluation, because we can uh, Iceberg supports schema, dynamic schema. So instead of breaking the downstream consumers the moment the data comes, we can do the schema validation and only merge when we are truly expecting that change, or we have the capability to handle the downstream systems when a schema evaluation happens. So yes, that simplicity is there. And summary wise, Iceberg write audit publish is as of now only available at table level. Nessie has this concept, Nessie catalog, which is, I think, by Dreamio team. They have built a catalog called Nessie. So the Nessie catalog does support this write, audit, and publish pattern across multiple tables, because they have multi-table transactions. And but as of now, by the default Iceberg implementation with Glue or other catalogs, it only supports at table level. It is very easy to use, extremely intuitive, and the syntax are very logical, and everything that we want can be done from the Spark SQL or PySpark as well. The only thing that we can't do is the merge, because for that we need a system call. So that we can't do it in SQL as of now. We have to do it via the Python or PyIceberg or system calls that is there. So this was it for this video. We have seen how we can implement uh, the write, audit, and publish pattern in Iceberg. Uh, If you like this, do spread the word, and do comment if you have anything that you want me to make video on. Thank you.